So you're probably here for the second part in my 3-part series explaining how ChatGPT actually works under the hood. Well, actually, this isn't the second part. This is a segue from the first part to the second part, because there's something extremely important that I still have to explain to you that I realize I have omitted. And this may be something that people already know about, and I plan to clarify it a little bit more. So it's this thing called generalization, and it really is at the heart of artificial intelligence and machine learning. You may remember right at the beginning, I defined machine learning as this ability to learn from data to make predictions without being explicitly programmed what to do. So I want to clarify that. I want to add a little bit more to it by saying that it's really about learning from data to make predictions in new situations not seen before without being explicitly programmed. Might sound like just a small little addition there, but it is really the key to machine learning. It's this ability to perform well on examples that are outside the training data that you saw during training. That property is known as generalization, and it is incredibly important, and I plan to show you exactly why. I want to take you back to that first example that we talked about a couple of videos ago about predicting the price of rent for apartments in buildings. And this time I want to imagine that we're looking at the same building, we're looking at data from the building, and every single apartment in the building is identical, same number of square feet. The only thing that varies is the floor number of the apartment. And let's suppose we've got some data, and it's pretty simple data. The apartment on the first floor has a rent of $1,000, second floor $2,000, then third floor $3,000. You can probably see the pattern here. We don't need a very sophisticated machine learning model to predict what's happening. We can plot that as a little chart, and we see a nice straight line, and of course we can imagine that that straight line should continue. And so a simple model that you might build would do exactly that. It would predict the next few points, and we'd assume that an apartment on the 4th floor would have $4,000 rent, and the 5th floor would be $5,000 rent. And that ability to predict on new floors like this, which in the graph you can think of as extrapolating outside our training data, that is called generalizing. But then something goes awry when we learn about the actual rent on the 6th floor. Turns out that the rent is $2,400, we discover. And that, of course, means that not only are we very wrong with our prediction on the 6th floor, but it calls into doubt our predictions for the 4th and 5th floors as well, because clearly we don't understand all the factors that are going into the rent price in this building. And let's suppose that our data scientists do more investigation and discover that what's going on is that this building is in fact a walk-up building. There's no elevator. And that means that beyond what's for the first few floors, the price increases because it's nice to get a better view. When you go above the 3rd floor, there starts to be a penalty because it is such a bore to have to walk up all these stairs. And in fact, that penalty depends in some way on the square of the floor. And it turns out that they come up with this penalty formula, and that predicts the $2,400 rent for the 6th floor perfectly. And then on more experiments, they discover that now their model is spot on for the 4th and 5th floors as well. So they are now performing better on data they haven't seen before for the 4th and 5th floors. And so this new revised model is able to generalize. And largely speaking, this is the objective of AI. The goal of AI is simply to generalize, to be able to make predictions on data that you didn't see during training time based on learning patterns from that training data. When it comes to traditional machine learning, the way you do that is by coming up with a hypothesis, a guess for how you might be able to model the data, maybe the floor number squared, the square feet, and then using different techniques, different models, pumping through your data and trying to adapt to the patterns. But it depends on someone, a data scientist, who has some domain knowledge of the field and is able to make these sensible, these educated guesses about how you might be able to explain the data. Modern AI is different. It doesn't depend on this kind of domain expertise or on coming up with these sorts of things called features, these things like square feet and floor number that might explain the data, but rather it takes enormous numbers of examples and huge numbers of parameters. Again, these mixers connected to mixers, these neurons connected to each other, and it automatically learns the patterns from the data without being given examples of hypotheses and features. The classic example of this is machine translation, writing computer programs that translate from one language to another. For many years, Google built out the Google Translate application with many language experts who wrote code with lots of rules, lots of interpretations of grammar and mapping, and lots of traditional machine learning to be able to translate from one language to another. But then they started to use deep neural networks, and rather than coding these rules, they simply gave it lots and lots of examples of the same content in two different languages and let it learn the patterns itself. And this, in the end, proved to be remarkably more performant. And in 2016, Google famously moved Google Translate from using more of the traditional approach to using deep neural networks, and they've never looked back. And now let me make this even more tangible for you. Last time I showed you ChatGPT answering that incredible question about the color blue and giving a detailed answer. And someone responded to me after I posted that and said, okay, but surely that must mean that it saw that question somewhere in its training data and that's what you're seeing, or a very similar question. And I tried to explain that no, that's not the case, that it could have done, but it doesn't need to have done because it is very effective at generalizing. So let's put that to the test. Here I am asking GPT-4o, ChatGPT, a question, a bizarre question that I am very confident is not in its training data. I said, in 2 words, how many smiles does it take to leap from Bermuda to pi? It's a pretty bizarre question, which I very much doubt is in its training data. And it's really interesting to see how it responds to something like that. And of course, it does a fabulous job. And the answer that it gave in 2 words was infinite joy. Just beautiful. And by the way, you can ask this question for 3 words, 4 words, 5 words. You get spectacular answers to whatever you say. But it's really interesting to see again this next token prediction, to see step by step what tokens was it predicting. It started by saying that the most likely token was the word infinite, but also abstract. And then presumably im is the beginning of imagination or imaginative or something. And these words, you can imagine, are all reasonable choices for a somewhat bizarre question that I asked it. And then for the second word, for what would come after infinite, it could have been infinite journey, infinite imagination, but it picked infinite joy, presumably triggered by the smiles. And then, of course, the next one was extremely likely to be a full stop because that was the end of the 2 words, which it could detect. It could also have been a question mark or an exclamation mark as well. So to say, as the heading for this slide, GPT-4o can generalize, that is surely the understatement of the year. GPT-4o can indeed generalize, and the way that it generalizes is magical. And that leads nicely to me wanting to restate the question that I said right back at the beginning of all this, which is I asked, how is it that ChatGPT is so very good at what it does? And I want to say that maybe another way to think about that, the question we should be asking is actually, how is ChatGPT able to generalize so very effectively? It wouldn't be a surprise if ChatGPT was simply able to regurgitate questions it had seen at training time. The thing that is so astonishing is it is able to come up with nuanced, intelligent responses to questions that it's never seen before, all by virtue of predicting next tokens really, really well. So that is the new way to frame the question that I intend to answer. And whilst there are many, many ways to explain it, perhaps the single most important factor is the way that it is trained. And so that concludes this segue. This takes us nicely from the G in GPT to the P. In the next video, we get to pre-training and I reveal a bit more of the secret sauce.